A shell script is a computer program designed to be run by the Unix shell, a command line interpreter. The various dialects of shell scripts are considered to be scripting languages. Typical operations performed by shell scripts include file manipulation, program execution, and printing text. Capabilities, shortcuts. In its most basic form, a shell script can provide a convenient variation of a system command where special environment settings, command options, or post-processing apply automatically, but in a way that allows the new script to still act as a fully normal Unix command. One example would be to create a version of ls, the command to list files, giving it a shorter command name of l, which would be normally saved in a user's bin directory as usernaml, and a default set of command options pre-supplied. Here, the first line indicates which interpreter should execute the rest of the script, and the second line makes a listing with options for file format indicators, columns, all files, and a size in blocks. The lc collate equals c sets the default collation order to not fold upper and lower case together, not intermix. Files with normal file names as a side effect of ignoring punctuation in the names, and the $@ causes any parameters given to L to pass through as parameters to ls, so that all of the normal options and other syntax known to ls can still be used. The user could then simply use L for the most commonly used short listing. Another example of a shell script that could be used as a shortcut would be to print a list of all the files and directories within a given directory. In this case, the shell script would start with its normal starting line of sh. Following this, the script executes the command clear, which clears the terminal of all text before going to the next line. The following line provides the main function of the script. The lsl command lists the files and directories that are in the directory from which the script is being run. The ls command attributes could be changed to reflect the needs of the user. Note: if an implementation does not have the clear command, try using the clr command instead. Batch jobs. Shell scripts allow several commands that would be entered manually at a command line interface to be executed automatically, and without having to wait for a user to trigger each stage of the sequence. For example, in a directory with 3 C source code files, rather than manually running the 4 commands required to build the final program from them, one could instead create a C shell script, here named build and kept in the directory with them, which would compile them automatically. The script would allow a user to save the file being edited, pause the editor, and then just run. /build to create the updated program, test it, and then return to the editor. Since the 1980s or so, however, scripts of this type have been replaced with utilities like make, which are specialized for building programs. Generalization: simple batch jobs are not unusual for isolated tasks, but using shell loops, tests, and variables provides much more flexibility to users. A bash script to convert JPEG images to PNG images, where the image names are provided on the command line possibly via wildcards instead of each being listed within the script, can be created with this file, typically saved in a file like usernimg2png. The jpg2png command can then be run on an entire directory full of JPEG images with just usernimg2png jpg. Verisimilitude: a key feature of shell scripts is that the invocation of their interpreters is handled as a core operating system feature. So rather than a user's shell only being able to execute scripts in that shell's language, or a script only having its interpreter directive handled correctly if it was run from a shell, shell scripts are set up and executed by the OS itself. A modern shell script is not just on the same footing as system commands, but rather many system commands are actually shell scripts. This extends to returning exit codes like other system utilities to indicate success or failure, and allows them to be called as components of larger programs regardless of how those larger tools are implemented. Like standard system commands, shell scripts classically omit any kind of file name extension unless intended to be read into a running shell through a special mechanism for this purpose. Programming: many modern shells also supply various features usually found only in more sophisticated general-purpose programming languages, such as control flow constructs, variables, comments, arrays, subroutines, and so on. With these sorts of features available, it is possible to write reasonably sophisticated applications as shell scripts. However, they are still limited by the fact that most shell languages have little or no support for data typing systems, classes, threading, complex math, and other common full language features, and are also generally much slower than compiled code or interpreted languages written with speed as a performance goal. Other scripting languages. Many powerful scripting languages have been introduced for tasks that are too large or complex to be comfortably handled with ordinary shell scripts, but for which the advantages of a script are desirable and the development overhead of a full-blown, compiled programming language would be disadvantageous. The specifics of what separates scripting languages from high-level programming languages is a frequent source of debate. But generally speaking, a scripting language is one which requires an interpreter. Life cycle: shell scripts often serve as an initial stage in software development, and are often subject to conversion later to a different underlying implementation, most commonly being converted to Perl, Python, or C. The interpreter directive allows the implementation detail to be fully hidden inside the script, rather than being exposed as a file name extension, and provides for seamless re-implementation in different languages with no impact on end users. Advantages and disadvantages: perhaps the biggest advantage of writing a shell script is that the commands and syntax are exactly the same as those directly entered at the command line. The programmer does not have to switch to a totally different syntax, as they would if the script were written in a different language, or if a compiled language was used. Often, writing a shell script is much quicker than writing the equivalent code in other programming languages. The many advantages include easy program or file selection, quick start, and interactive debugging. A shell script can be used to provide a sequencing and decision-making linkage around existing programs, and for moderately sized scripts the absence of a compilation step is an advantage. Interpretive running makes it easy to write debugging code into a script and rerun it to detect and fix bugs. Non-expert users can use scripting to tailor the behavior of programs, and shell scripting provides some limited scope for multiprocessing. On the other hand, shell scripting is prone to costly errors. Inadvertent typing errors such as RMRF/ are folklore in the Unix community. A single extra space converts the command from one that deletes everything in the subdirectories to one which deletes everything and also tries to delete everything in the root directory. Similar problems can transform CP and MV into dangerous weapons, and misuse of the redirect can delete the contents of a file. This is made more problematic by the fact that many Unix commands differ in name by only one letter: CP, CD, DD, DF, etc. Another significant disadvantage is the slow execution speed and the need to launch a new process for almost every shell command executed. When a script's job can be accomplished by setting up a pipeline in which efficient filter commands perform most of the work, the slowdown is mitigated, but a complex script is typically several orders of magnitude slower than a conventional compiled program that performs an equivalent task. There are also compatibility problems between different platforms. Larry Wall, creator of Perl, famously wrote that it is easier to port a shell than a shell script. Similarly, more complex scripts can run into the limitations of the shell scripting language itself. The limits make it difficult to write quality code, and extensions by various shells to ameliorate problems with the original shell language can make problems worse. Many disadvantages of using some script languages are caused by design flaws within the language syntax or implementation, and are not necessarily imposed by the use of a text-based command line. There are a number of shells which use other shell programming languages or even full-fledged languages like SCSH. See also, glue code, interpreter directive, shebang symbol, Unix shells, Windows PowerShell, Windows script host, references. External links, an introduction to shell programming by Greg Gerbel, Unix/Linux shell scripting tutorial by Steve Parker, shell scripting primer, what to watch out for when writing portable shell scripts by Peter Siebsch, free Unix shell scripting books.